Hey there and welcome back. Last time, we got really good at multiplying a single term into a polynomial. Well, today, we're going to level up and take the next big step, multiplying two binomials together. So let's jump right in.
All right, here's our game plan. We'll start with a super quick refresh on distribution. Then I'll show you a really cool visual model to keep things organized. We'll run through a couple of examples, talk about a popular shortcut, and then wrap up with a final self-check so you know you've got this down cold.
So you've totally got this down, right? Something like 3 times the quantity x plus 5. You know exactly what to do. You distribute that 3. But what happens when that 3 on the outside gets replaced by a whole other binomial, like x plus 2? How do we handle that? Well, that's the big puzzle we're going to solve today.
To tackle this new challenge, we're not going to learn some crazy new rule. Nope. We're actually just going to build on something you already know, like the back of your hand.
You remember this guy, right? The distributive property. It's that super simple idea, whatever's on the outside of the parentheses has to multiply times every single term on the inside. And that core idea, multiply everything by everything, that is the absolute key for today.
Okay, but now that we have two binomials, things can get a little messy. There's just more pieces to keep track of. So we need a good, solid way to organize ourselves. And you know what? A visual model is perfect for this.
Let's picture it like this. Think about finding the area of a simple rectangle. You already know the formula, right? It's just lengths times width. Well, we can actually imagine that one of our binomials is the length and the other one is the width.
And setting up this area model is super easy. All we do is draw a simple 2x2 box. We take the first binomial and write its terms across the top, one term per column. Then we grab the second binomial and write its terms down the side, one term per row. That's it.
Okay, this right here, this is the most important sentence of the day, the golden rule. It doesn't matter what method you end up using, the goal is always the same. Every term in the first binomial has to multiply every term in the second one. The area model we're using, it's just a fantastic way to make sure we don't accidentally forget a piece.
Okay, enough talk. Let's actually put this model to work with that first problem we looked at.
All right, now we just fill in the 4 empty boxes. And to fill a box, you just multiply its row header by its column header. So, top left, that's x times x, which is x squared. Easy. Top right, that's x times 5, which gives us 5x. Moving down, bottom left is 2 times x, so 2x. And finally, bottom right is 2 times 5, which of course is 10.
And just like that, the multiplication part is done. See? Inside that box are our 4 brand new terms. All we have to do now is pull them out of the box and write them down in a line.
Okay, last step is always to tidy things up. We just look for any like terms that we can combine. And yep, I see a 5x and a 2x. Let's put those together. 5x plus 2x gives us 7x. So our final, beautiful, simplified answer is x squared plus 7x plus 10. Boom!
Okay, that was great, but you know how algebra is. It loves to throw a little curveball at us, usually in the form of a negative sign. The good news? The process is exactly the same. We just have to be extra careful with our signs. Let's check out this next one.
So we set up the box the same way. Now let's fill it in, paying close attention. 2x times x, that's 2x squared. No problem. 2x times 5 is a positive 10x. But here we go. Now we're using the negative 3. So negative 3 times x gives us negative 3x. And negative 3 times positive 5 gives us negative 15. See how important it is to watch those signs?
All right, let's pull our 4 terms out of the box. We've got 2x squared, a positive 10x, a minus 3x, and a minus 15. Time to combine the like terms. 10x minus 3x leaves us with a positive 7x. And there we have it, our final answer, 2x squared plus 7x minus 15.
Okay, so now that you've seen why this works, that we're really just making sure everything multiplies everything, let's talk about a super common shortcut you're going to hear about. And I want to be clear, this is not a new math rule. It's just a little memory trick to help you remember those 4 multiplications.
And that acronym is FOIL. F-O-I-L. It's just a way to remember the 4 pairs you need to multiply. F is for the first 2 terms, O is for the 2 outer terms on the edges, I is for the 2 inner terms squished in the middle, and L is for the last 2 terms in each binomial. It's literally just a checklist to run through.
So, area model versus FOIL. Which one is better?
Honestly, it doesn't matter one bit. They both do the exact same job. They make sure you get those 4 products. The area model is awesome if you're a visual person and like having things organized in a box. FOIL is great if you just want a quick list to follow. My advice? Use whichever one makes more sense to you.
All right, before I set you loose to try some of these on your own, I want to give you a quick little self-check you can use. It's a simple way to catch those little mistakes before they become big ones. Okay, 3 quick questions to ask yourself. Number 1, did I get 4 terms before I started combining things? If you only got 2 or 3, you missed a step somewhere. Number 2, and this is the big one, did I double-check the sign of every single term? That's where most mistakes happen. And number 3, did I combine all the like terms? If you can say yes, yes, and yes, then you are golden.
So there you have it. You now have the skills to multiply 2 binomials together. Pretty cool, right? So here's a little something to chew on. How could you use these same ideas, especially the area model, to multiply something even bigger? Like, say, a binomial times a trinomial. What would that box have to look like? Give that some thought. Thanks so much for tuning in.